In the second part of 3.3, you are going to learn a couple new strategies for dealing with limits. But the first step for all limits is going to still remain the same. We are going to substitute in directly and see what we get. When we do that in this first example, we're going to get 0 over 0, and that's going to happen a lot, but it's important for us to remember what that means, that there's a hole there, that it's indeterminate, and that requires us to figure out what the rest of the graph looks like when there's just that one little gap in the graph, which we call a hole. Simplifying requires us to do operations. So if I look at this expression, notice first of all that I'm going to write my limit expression down unless I am replacing h with 0. I'm not doing that right now, so I must include that limit expression. And every time you simplify these, what you're going to find is that the problem, or the 0, in this case in the denominator, the h on the bottom, is going to cancel out. 9 plus 3 is 12, minus 12 is 0. These are all going to cancel out. So what we're going to do then is divide everything by h, or take an h out and cancel it out. And either way you look at it, you get the same result. You're going to get 6 plus h minus 4. And when I replace h with 0 now, because I've dealt with the h on the bottom, I'm simply going to get 2. That is the limit as h approaches 0. You're also going to end up with some questions involving division. In order to do this, you're going to need to get a common denominator to deal with the question, and then remember to multiply by the reciprocal. Again, when you put 10 in, the problem is right here, so that's going to be the part that cancels out. Similarly here, when we put in 3, where's the problem? Right there. We're going to end up with 0 over 0. We're going to get a common denominator again, this time multiplying by x plus 2 here, and x minus 2 here, simplifying and canceling out the, not necessarily the problem, I guess, really. It's just what is there, and that is the denominator. So when we look at this root function, how are we going to deal with this one? A little bit different strategy than just simplifying. We're going to have to rationalize it. Before I do, I'm going to put in 6, and when I put in 6, I get 0 over 0, and you're going to show me each time that you understand that that means there's a hole when the r value is 6 and it behaves different everywhere else. So the strategy is called rationalizing, and you've rationalized lots. Sometimes we call it booting the root, or to boot the root. And when you did the basic rationalizing, you multiplied by just the root. That won't help us here. So what we're going to do is we're going to multiply by the conjugate of the root, or the conjugate of the expression with the root, in the numerator and the denominator, which is the same as multiplying by 1. When we do that, notice again, I'm still not replacing my r value with 6, so I'm going to leave the limit expression in. Please do that as you do your assignment. And when I multiply it out, a root times a root is itself. Middle terms will cancel out because they're conjugates. And then minus 9 on the bottom, or in the term that did not have the root, do not multiply it out. If you do, you won't see the canceling that's going to happen. So I'll show you in the numerator, you simplify it, you're going to get r minus 6. Those divide out and leave you with 1 on the top. Now we go back to direct substitution, put in 6, you're going to get 1/6 as your answer. And that's it. You're going to run into some more problems that look more difficult, but all it's going to take is a little practice. You can do this assignment on page 138, and I will be glad to help you out.